Today we will cover some things that the other videos from YouTube did not. So first of all, there is a pace that evolution can occur, or how quickly it can occur. The first one is gradualism, and the second one is punctuated equilibrium. So for gradualism, this moth does not look much different from month to month. However, if you look at it over the course of 5 months, it looks very, very different. This is very gradual change. You can hardly tell from day to day. It is only when you stand far back and look at it from month to month or year to year that you can see this. Sometimes it even takes decades to notice a difference. In contrast to that, we have punctuated equilibrium. Punctuated equilibrium means that a creature does not change. That is what equilibrium is. When a creature does not evolve, it is said to be in equilibrium. However, we punctuate that with rapid change here and here. This is usually the result of something drastic changing in the environment, which demands that the organism quickly change rather than slowly. And so those are the two types of paces we see. I also want to talk about the fact that there are different ways to evolve. Evolving is just a change in your allele frequencies. There are ways to do that. The first way is a selective process, and the second way is a random process. So it can happen randomly and not randomly. Selective processes include natural selection and artificial selection. Random processes include genetic drift and gene flow. So evolution can occur randomly, or it can follow a pattern. If we're talking about selective processes, what does it mean to select? If it is nature that is selecting, like for example, a tall branch selecting for tall giraffes, that would be natural selection. However, if people are the ones that are choosing, that is artificial selection. And of course, we've already talked a lot about natural selection. This is a theory that Charles Darwin came up with, along with Wallace. What are the rules for selection? For selection to begin at all, you need variation. Without variation, there is nothing to select from. In these two pictures, there is no selection here. There's nothing to choose from, only green. However, here, there is selection. For anything that is selective, including natural or artificial selection, you need variation. And then something has to select. If it is nature, it is natural selection. If it is people, it is artificial selection. We will now go over the rules of natural selection as proposed by Charles Darwin. The first rule, of course, is variation, which we have just discussed. The second rule is there is a struggle. And the third rule is the survival of only the fittest. And we'll talk about which each of those means one at a time. Here we can see variation in these lions. Variation is needed. That is the first part of natural selection. Without it, organisms cannot properly evolve and may go extinct instead. In nature, it is adapt or die. You either evolve as a species or you go extinct. And so, variation is needed for that. Variation may be good for the organism or bad or neutral. An adaptation is a good variation. It is a variation which increases fitness. We've talked about fitness before. Fitness is the ability to survive and reproduce in that order. What determines if a variant is good or bad? It is the environment. So for example, in these two foxes, we have the fennec fox and we have the Arctic fox. Their variation is fur length. The Arctic fox has very thick fur, and the fennec fox has very short fur. These are variants. What determines if those variations are good? It is the environment. And so the fennec fox has an adaptation for short fur because the environment is hot. However, if you were to place the fennec fox into the Arctic, it would not be a good variant. It would be a bad variant. It would no longer be an adaptation. So what determines if a variant is good or bad? It is the environment. What causes variations in the first place? Mutation. A mutation occurs when a letter from DNA is either changed, deleted, or added. Here we can see that this used to be a T, but it has changed to a G. This mutation creates a brand new allele. Mutations are what create genetic variation. Without mutations, no organism would ever change. And so mutations can create good alleles, bad alleles, or neutral alleles, where there is no change in phenotype. Sexual reproduction is another form of variation because it mixes alleles between two individuals. And so those are the two sources of variation. We will skip this for now. The second rule of natural selection is there is a struggle. As was proposed by Malthus, the statistician, there is always more organisms born than can survive. This is because we do not live in a perfect world where all resources are boundless. There is always a carrying capacity in every environment. Because of this carrying capacity, organisms must compete, and it is only the strongest in terms of fitness that survive. The most fit individual is not necessarily the biggest and the strongest. It is simply the one that can survive the best and reproduce the most. And so the second rule of natural selection is that there is a struggle. This competition can be between members of the same species or between two different species. This idea came from Malthus, this guy here, who Charles Darwin read about, as well as Wallace. They both read Malthus, and they realized by his studies of these crowded streets of London that the more crowded an area with organisms, the more competition there is. And because there is not limitless resources in the world, we must fight for survival. The third rule of natural selection is that after the struggle, there is only survival of the fittest. And so what does fitness mean? Well, it doesn't necessarily mean the biggest. Here we can see a quote by Darwin. He says, "Only the weak die. Strong and healthy is always a winner in the struggle for existence." But what does it mean to be strong? If we look at these rabbits here, which of these rabbits might you suspect is the most fit of the three? Most of you will see the big rabbit and think that this must be the most fit. But remember, variants are only good or bad depending on the environment, like with our foxes. Variations are only good or bad depending on the environment. And so, what is the environment? This is a trick question because I have not given you an environment. So let me give you an environment. Within an environment, there are selective pressures. Selective pressures determine the course of evolution. Here we can see tall grass, and we can see a predator. Knowing these selective pressures, one of them being a positive selective pressure and the other a negative, which of these three rabbits is now the most fit? You should have selected the smallest rabbit because it can most easily hide in the grass. It gets the most benefit from the positive pressure and the least penalty from the negative.